ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ನಾನ್ ಹೋಮೋಜಿನಿಯಸ್ PDE ಬೈ ಡೈರೆಕ್ಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಹೋಮೋಜಿನಿಯಸ್ ಮತ್ತು ನಾನ್ ಹೋಮೋಜಿನಿಯಸ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ಸ್ ಅಂದರೆ ಅಂತ ಫಸ್ಟ್ ತಿಳ್ಕೊಳ್ಳೋಣ. ದೆನ್ ವಿ ಕ್ಯಾನ್ ಎಕ್ಸ್ಟೆಂಡ್ ದಟ್ ಟು PDE. See, generally any differential equation can be written in this form: f of d into y equal to phi of x. If the right hand term phi of x is equal to 0, see, if this term is equal to 0, then we call such differential equation as homogeneous. If the right hand term is 0, then we call that equation, differential equation, as homogeneous. So generally any homogeneous differential equation will be of this form. If this term is not equal to 0, then we call this differential equation as non-homogeneous. Non-homogeneous. So generally it will be of the form f of d into y equal to phi of x with phi of x not equal to 0. Same concept is extended to now PDE, partial differential equations, and in this video we are going to discuss how to find the solution of a non-homogeneous PDE by using direct integration method. If you get any doubt about a non-homogeneous or homogeneous PDE, how the classification is done, if you have any doubt, just forget about it. Just we are think that we are going to find the solution of a PDE by using direct integration method. Keep that in mind. Now solution, let us explain the method with a simple example. Given a differential equation, what do you mean by the solution? That's first we have to discuss. What do you mean by the solution of a differential equation? I have a simple example here. dy by dx equal to x, I will write. What do you mean by the solution of this differential equation? The solution of this differential equation means finding y. Finding what is the dependent variable. So that will be the solution of the given differential equation. Let us take one more simple example. Suppose see, we'll write f of x equal to x square plus minus 2x plus 1. Now what do you mean by the solution of this equation? This equation, in the sense I have to take f of x equal to 0. What do you mean by the solution of this equation? That is the value of x which satisfies this equation. Solution means the value of x which satisfies this equation. If you take x equal to 1, that satisfies this condition. That means you get f of 1 equal to 0. Same thing is happening here. The solution of the given differential equation means the value of y which satisfies the given differential equation. Now we are going to find the solution of the given partial differential equation. That means we are going to find the dependent variable of the given partial differential equation by using direct integration method. Let us start with the problem solution. Number 1, solve dou square u by dou x square equal to x plus y. So that is the first problem we are going to consider. Dou square u by dou x square equal to x plus y. Here what is our intention? Our intention is to find u. What is the value of u satisfying this PDE? That is our intention. Solution given dou square u by dou x square equal to x plus y. So that is the given differential equation. I can write this as dou by dou x of dou u by dou x equal to x plus y. Hoda? We can write in this form, no doubt about it. Now I have to remove this one. My intention is to remove this one. Then I have to remove this remaining so that I'll get u. How can we remove this part? By using integration. So since we have here derivative, we need to integrate this to remove that derivative. With respect to which variable we have to integrate? That is the question. Here we have x, we have partial derivative with respect to x. So that to remove the partial derivative with respect to x, I have to integrate with respect to x. While integrating with respect to x, I have to keep y as constant. So integrating with respect to x, I'll get this will be removed, dou u by dou x equal to integral of x plus y dx, plus, see, I have to write some constant term. Constant term should be derivative of that with respect to x must be 0. Constant term ಯಾವ ರೀತಿ ಬರೀಬೇಕಂತಂದ್ರೆ with respect to x ಅದನ್ನು differentiate ಮಾಡಿದ್ರೆ 0 ಆಗಿಬಿಡಬೇಕು. Why? See, if you differentiate this expression, I should get this one. Here you have just x plus y, so the remaining will be 0. So you have to write the constant term such that the derivative of that with respect to x should be 0. With respect to x, keep that word in mind. Derivative of that term with respect to x should be 0. So that constant term may be function of y, because while differentiating partially with respect to x, y will be constant. So I have to write f of y. Now dou u by dou x will be, so that implies, see, I can write this dou u by dou x as dou by dou x of u equal to integral of x plus y with respect to x, that will be integral of x square by 2, plus integral of y with respect to x, that will be x y plus f of y. Now integrating again with respect to x, this derivative part will be removed, so you will get u equal to integral x square by 2 dx plus integral xy dx plus integral f of y dx. Again I need to add one more constant term that should be free from x, but it may involve y, so g of y. So that implies u equal to x 1 by 2 into integral of x square, that is x cube by 3, plus y into integral of x, that is x square by 2, plus x into f of y, plus g of y. So the solution is u equal to x cube by 6 plus x square y by 2 plus x f of y plus g of y. That is the required solution. So let us consider one more problem. B, solve dou square z by dou x dou y, equal to x by y plus a. Solution. So given dou square z by dou x dou y equal to x by y plus a. So I can write this as dou by dou x of dou z by dou y equal to x by y plus a. Now see, I have dou by dou x. To remove that, I have to integrate with respect to x, keeping y as constant. Here our intention is to find z. Integrating with respect to x, I'll get dou z by dou y equal to integral of x by y into dx, okay, integral of x by y plus a into dx plus the constant term f of y. Now integrating this, say I can write this term as dou by dou y of z equal to integral of x by y. I am integrating with respect to x, ಹೌದಲ್ವಾ? So 1 by y into integral of x, that is x square by 2, plus constant into integral of dx, that is x, plus f of y. Now integrating with respect to y, integrating with respect to y, I have to treat x as constant. So integrating this with respect to y, this term dou by dou y will be removed. So I will get z equal to integral of x square by 2 into 1 by y dy plus integral ax into dy plus integral f of y into dy plus the constant term. See, here we have integrated with respect to integrating with respect to y. So this constant term should be free from y. It may be g of x. So z equal to x square by 2 will be constant term. So x square by 2 will be outside. 1 by y, if you integrate, you get log y. Plus here ax will be constant term. Integration of dy, integration and differentiation cancels. You get y plus, you can write integral f of y dy as it is, no problem, or you can write this as capital F of y plus g of x. So this is the required solution. Now let us take one more. See, solve dou cube z by dou x square dou y equal to cos of 2x plus 3y. Solution. Given, I'll write this as dou by dou x of dou square z by dou x dou y. Sorry, it is not dou y square, this is just dou y. Dou by dou x of dou square z by dou x dou y equal to cos of 2x plus 3y. Now differentiating, integrating, it is integrating with respect to x, integrating with respect to x. So this dou by dou x will be removed. You get dou square z by dou x dou y equal to integral of cos of 2x plus 3y into dx plus f of y. Now this will be, I can write this left hand term as dou by dou x of dou z by dou y equal to dou by dou x of dou z by dou y equal to sin of 2x plus 3y. I am integrating cos of 2x plus 3y term, so I will get sin of 2x plus 3y divided by, in the denominator you have to write the derivative of this inner function, that will be 2 plus f of y. Now to remove dou by dou x again, integrating with respect to x, integrating with respect to x. So left side will be dou z by dou y, dou by dou x will be removed, you get dou z by dou y equal to this 1 by 2 I can take outside, integral of sin of 2x plus 3y dx plus integral f of y dx plus g of x. I mean integrating with respect to x, right? So it will be g of y. Now dou z by, or you can write dou by dou y of z equal to 1 by 2 into integrating a sign, you get minus cos of 2x plus 3y divided by differentiating this inner term with respect to x, again you get 2 plus integral, this f of y will be constant into integral of dx, you will get x f of y plus g of y. So this will be, you can write once again, minus cos of 2x plus 3y divided by 4 plus x f of y plus g of y. Next, now integrating with respect to y. Integrating with respect to y. So I'll get left hand side z equal to minus 1 by 4 times integral of cos of 2x plus 3y into dy plus integral x f of y dy plus integral g of y dy. Okay, this will be z equal to minus 1 by 4 आगे रहता है. Now cos of 2x plus 3y, integrating that with respect to y, you will get sin of 2x plus 3y divided by, in the denominator, derivative of inner function 3 plus x into integral of f of y dy plus this I can write as capital G of y, One more thing I have forgotten here, adding constant term, say some h of x. So plus h of x. This again I can take as capital F of y. See, if you get any doubt, you can keep that as it is, no problem. Z equal to minus sin of 2x plus 3y divided by 12 plus x into capital F of y plus g of y plus h of x. Or else you can write this as minus 1 by 12 into sin of 2x plus 3y plus x into integral f of y dy plus integral g of y dy plus h of x. Nothing wrong in that. You can keep as it is. Next problem. This is a bit lengthy one. Solve dou square z by dou x dou y equal to sin x sin y, for which dou z by dou y equal to minus 2 sin y equal to minus 2 sin y when x equal to 0, and z equal to 0 if y is odd multiples of pi by 2. That is given in words, but I will write it in symbols. When y is odd multiples of pi by 2. Solution. So look into the given problem statement carefully. You have to solve dou square z by dou x dou y equal to sin x sin y. That is the first thing. Next, you have to use the conditions dou z by dou y equal to minus 2 sin y when x equal to 0 and z equal to 0 when y is odd multiples of pi by 2 to determine the constants that appears in the solution. Illella constants banditala f of y, g of y, ee riti constants barutte. So to determine the value of that constants, I have to use the given conditions. Solution. Given dou square z by dou x dou y equal to sin x sin y. This we can write as dou by dou x of dou z by dou y equal to sin x sin y. Okay. Now integrating with respect to x. Integrating with respect to x. So I'll get dou by dou x will be removed. I'll get dou z by dou y equal to integral of sin x sin y dx plus the constant f of y. Now I can write this as dou by dou y of z equal to, see here I have integral of sin x sin y with respect to x, so sin y will be constant. Integral of sin x will get minus cos x. Integral of sin x you get minus cos x plus f of y. Now integrating with respect to y, I'll get z equal to integral of sin y minus cos x terms आगे ಬರ್ಕೊಂಡಿದ್ದೀನಿ ನಾನು ಅಷ್ಟೇ dy plus integral f of y dy plus g of x. So that implies z equal to minus cos x constant, minus cos x into integral of sin y with respect to y, that is minus cos y, plus integral of f of y, you can write that as capital F of y plus g of x. So that implies z equal to cos x cos y plus f of y plus g of x. Okay, this is z. That is the actual solution. Now we need to determine the constants by using the given conditions. Call this as, do one thing, call this as equation 1, this is equation 2. Why we call this as equation 1? Because this I have to reuse. This. Given dou z by dou y equal to minus 2 sin y when x equal to 0. This is the condition. X 0 ಆಗಿದ್ದಾಗ dou z by dou y the value minus 2 sin y ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. Using this in 1, equation 1, what we get? Dou z by dou y value minus 2 sin y ಆಗುತ್ತೆ equal to ಇಲ್ಲಿ minus sin y into cos 0, because x value is 0, cos 0 plus f of y. So that means minus 2 sin y equal to, anyway cos 0 is 1, I can take this minus sin y to this side plus sin y equal to f of y. So f of y is minus sin y. Integrating with respect to y, obviously. Integrating, I'll get integral f of y dy, which is equal to integral of minus sin y, that you get cos y. Integral of minus sin y, you get cos y. But integral f of y dy is capital F of y. So I got capital F of y equal to cos y. Capital F of y is cos y. Next, the second condition. Given that z equal to 0 when y is odd multiples of pi by 2. Z equal to 0 when y is odd multiples of pi by 2. See, I have z equal to cos x cos y plus f of y plus g of x. And we know that cos of odd multiples of pi by 2 is always 0. Thus, from equation 2, 0 equal to, because z value is 0, 0 equal to cos x into cos of y into, cos of 2n plus 1 pi by 2 plus f of y plus g of x. But f of y value kuda sikkide namge. So 0 equal to, this term will be 0. So 0 into cos x, you get 0 plus, what is f of y? F of y is cos y. Again adu 2n plus 1 into pi by 2 agutte. Why? Because the value of y is odd multiples of pi by 2. That implies g of x equal to 0. Substituting these values in 2, and z equal to cos x into cos y plus capital F of y, that is cos y, plus g of x, that is 0. So cos y times cos x plus 1. That is the required solution. There is one more problem similar to this. Let us try to solve that also. Solve, I think it is problem E. Solve dou square u by dou x dou t, dou square u by dou x dou t equal to e power minus t cos x given u equal to 0 when t is 0. First condition, and dou u by dou t is 0 if x equal to 0. There is one more. Also show that u tends to sin x as t tends to infinity. Let's see whether this condition holds. Solution. Given, first to find the solution of this PDE. Given dou square u by dou x dou t equal to e power minus t cos x. See, here the dependent variable is u, independent variables are x and t. I can write this one as dou by dou x of dou u by dou t equal to e power minus t cos x. Now integrating this with respect to x first, integrating with respect to x. So we get dou u by dou t equal to dou u by dou t equal to integral e power minus t cos x dx plus f of t. y ಬದಲು t ಯೂಸ್ ಮಾಡೋದು ಅಷ್ಟೇ. So that implies dou by dou t of u equal to e power minus t is a constant, so e power minus t into integral of cos x, you get sin x plus f of t. Now integrating this with respect to t, you can call this as 1 because I have to reuse this. Integrating with respect to t, so I'll get u equal to integral e power minus t sin x dx, sorry it is dt, yes, dt plus integral f of t dt plus g of x. Now u equal to e power minus t, if you integrate e power minus t divided by minus 1, that is minus e power minus t sin x plus capital F of t plus g of x. Now using the given condition, it is given that dou u by dou t is 0 when x is 0. Using in equation 1, using that in equation 1, we'll get dou u by dou t, left side 0, equal to e power minus t into sin 0 0 plus f of t. So I'll get f of t 0. So capital F of t is 0, since you have the integrand small f of t is 0. So I got capital F of t 0. Next condition is u is 0 if t is 0. U is 0 if t is 0. Given u equal to 0 if t equal to 0. So using this, using it in equation 2, what do we get? 0 equal to minus e power 0 is anyway 1 into sin x plus f of t is 0 plus g of x. So from this I got g of x equal to sin x. G of x equal to sin x. Thus substituting this in equation 2, therefore z equal to, u, it is u equal to minus e power minus t into sin x plus capital F of t is 0 sin x. Or if you take sin x outside, this will be u equal to sin x times first term will get minus e power minus t. So sin x taking outside, it will be 1 minus s, I can write like this, 1 minus e power minus t. Now as t tends to infinity, e power minus t tends to 0. See, as t tends to infinity, e power t tends to infinity. So that implies e power minus t tends to 0. So u must tend to sin of 1 minus 0, sin x into 1 minus 0, that is sin x. So u tends to sin x as t tends to infinity. That completes the solution of that PDE. There is one more problem like this. I'll try to solve this. Solve, I think it is F, solve dou square z by dou x square equal to xy subject to the conditions dou z by dou x equal to log of 1 plus y when x equal to 1 and z equal to 0 when x equal to 0. So I had to solve this taking this problem as exercise. So finally I had to get the answer z equal to x cube y by 6 plus x into log of 1 plus y minus 1 by 2 into y. So finally I will take one more problem that is of a different kind. The problem statement is a bit different, that's all. Solve dou z by dou x equal to 2x plus y and dou z by dou y equal to x minus 2y. ಸಿ ಮುಂಚಿನ ಪ್ರಾಬ್ಲಮಲ್ಲೆಲ್ಲ ಒಂದೇ ಈಕ್ವೇಷನ್ ಕೊಟ್ಬಿಡ್ತಾ ಇದ್ವಿ, ಡೈರೆಕ್ಟಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದಾಗಿತ್ತು. ಬಟ್ ಇಲ್ಲಿ ಪೇರ್ ಆಫ್ ಈಕ್ವೇಷನ್ಸ್ ಆರ್ ಗಿವನ್. Solution, just apply direct integration, that's all. Given dou z by dou x equal to 2x plus y and dou z by dou y equal to x minus 2y, that's all. That is the given statement. Integrating, so ನಾನು ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲಿಸಿಟ್ ಆಗಿ ಬರೆಯೋಕೆ ಹೋಗಲ್ಲ, ಹಾಗೆ ಬರೀತಾನೆ. ಇಂಟಿಗ್ರೇಟಿಂಗ್, ದಟ್ ಈಸ್ ಅಂಡರ್ಸ್ಟುಡ್. The first equation, this you have to integrate with respect to x, this integrate with respect to y. Well, integrating with respect to x, keep y as constant. Integrating with respect to y, keep x as constant. So I'll get z equal to integral of 2x plus y into dx plus f of y. That is from this one. So from this, z equal to integral of x minus 2y into dy plus g of y, sorry, g of x it is. So that implies z equal to, I have to integrate this with respect to x, alva? So 2 into x square by 2 plus xy plus f of y. So from this, z equal to xy minus 2 into y square by 2 plus g of x. Now, so I got z equal to x square plus xy plus f of y. Call this as equation 1. On the other hand, z equal to xy minus y square plus g of x. Call this as equation 2. Now equation 1 and 2 left hand sides are same, so equating 1 and 2, so I'll get x square plus xy plus f of y equal to xy minus y square plus g of x. So xy x square cancels, and here see you have x square and here you have g of x. G of x means that represents a term which contains only x, so you can equate these two. So I'll get g of x, by comparison g of x you can take x square. Similarly here you have f of y, here you have minus y square. So now you can substitute either for f of y in equation 1 or for g of x in equation 2. So from equation 1 we'll be having z equal to x square plus xy minus y square. That is the required solution. So this is about the solution of PDE by direct integration. With this I am winding up of this